This video we're going to talk about a complex number, but today a complex number in a geogram. Basically how to put them in geogram. It's as simple as this. We're going to simplify and make it simple for you to understand it. Basically, let's say we've got geogram in here. We've got two axes in here, which is axis of x and of y. Basically, this is what we used to say in maths a lot. Is that simple? We've got here numbers, basically 1 to split it, and they have symmetric numbers for 0. We call it be -1, -2, -3 for the axis of x, and then here for the axis of y is the same thing. We got 1, 2, 3, -1, -2, -3, etc., etc. Then this is for a real number, how we do it. But now we are talking about complex number. Basically, for the complex number, just to recap, we said complex number is just like the whole space of numbers, a whole group of numbers. We represent them by z equal x plus I times y. It's basically here, and we said we've got real number in here. This is the real number, and this is imaginary number. We represent this by r a imaginary by I m. So basically imaginary stand for imaginary, and this is stand for real number. It's the same. How to represent them is the same as we represent any real number in the past. We got it's like the coordinate in the past. Let's say in the real number, we got real number. Let's say we named it a. We've got x equal 3 basically, and then y equal 1. We go here 3, x equal 3, 1, 2, 3, and then y 1 here, and then this is our letter, or our number. We named it a in the real number. But now we are talking about complex number. As simple as this, complex number is similar, but here we got real and imaginary. Basically, this is x, this is y. We've got here, it's the same. We've got our geogram. We've got axis of x become real, axis of real numbers. Axis of y, axis of x is this one, become axis of real numbers, and then axis of y become axis of imaginary number, just that. And then in here, any example, let's say we've got this real number, which is, we can write it this way in here, z equal 3 plus, it's the same example, 1 times I. Basically here we've got for real number, the real number is 3, 1, 2, 3, here 3, and the imaginary number is 1. We've got here 1, 2, 3, this is 1, and then here is our z. Basically as simple as this. And then we can do it for any other complex number. Here we have to represent it by a real number, and then here by imaginary number. As simple as this. You don't have to worry, there's nothing complicated. If you find any different names or something, it's just names has been given, or human being create that name. But theoretically and mathematically, just you have to represent it with these numbers there, as simple as this. That is the first concept. Second thing, now we've got this z. Basically we've got all this here. It's kind of here z. We can represent it here. We got 0 z here, this imaginary number. We can have two imaginary number. Let's say we've got z1, and then here's z1 3 plus 1 I, z2 let's say -2 plus, I would say, let's say 3 I. -2, -1 real number is -2. Basically -1, -2 goes in here, and then 3, we got 3y, 1, 2, 3, and then here -2. This is, we've called it, this is z2. Cool. And now we knew we can add it to two complex number together. We can basically distract as well. It's like basically take off. What we can do here, z1 plus z2, z1 plus z2. You can maybe do it in classroom or in different books. They would say you have to go to your geogram, add this here on the top, but I'm gonna show you that simple thing. What you have to do is just you have to add them two together. How to add them two together? Imaginary plus imaginary, real plus real, imaginary plus imaginary. The real result, then you have to represent it on your geogram, and then just make it straight up to keep it simple. That simple. This is safer for me, and this is what I would do, because sometimes you made a mistake when you put your your diagram in here, when you draw something, and then if you want to add them basically by just drawing without calculating, you might make the mistake. This is what I would say: calculate it first and then get to draw it, because by calculation you can see if you are right or wrong, and also it's simple and easy to do. All you have to do is just add the real with the real and imaginary with imaginary number, and then you got your final result. After that, you go to your diagram and then put the final results here in front of you, and then you can basically, that simple, you can write it down. Now, as simple as this, now we can move on slightly to more details in here. This is all basic and nice, simple and easy to go. And then now, let's say we've got all this in here from O till Z1, and basically this we can represent it by numbers as well in here, and we can see, because here we're gonna have an angle, here we're gonna have an angle, and here we're gonna have an angle too. It's basically just to make it simple for you to understand. Here angle, we're gonna call it, let's say gamma, just a name as well, gamma 1, and then here gamma 2. You can name it any name too. It's just here just to make a difference between complex number and what we call them and the angle. And then here what I can do, it's basically here we have to calculate first. We can calculate this here, the length in here, then for it, and then this angle in here. For this reason, we gave another two names for this complex number when we use diagram. Them two names are basically modulus. I'm gonna go through this, modulus, and argument. Cool. What's the modulus and what's the argument? As simple as this. Modulus is the length of this. This is the length of this. This is the length of this. If we got Z, another Z3, here the length, this one, we call that modulus is the length. It has to be, first thing, it has to be always positive. You can't say my length is -2. It doesn't exist. Let's say my length is 6 foot 2, 6 foot 4, 5 foot, 4 foot, something like that. You can't say -1 foot 2. Doesn't exist. It has to be always positive. Then for the modulus, how we can do it, we're gonna say Z1, let's say Z1 or Z or X or Y, any complex number is gonna be basically here x squared plus y squared square root of this. This is Z1. It has to be, and then Z1 will represent it with this way here. Basically, it's always has to be positive. Why we said this? Because we got here this triangle in here, and you got here this angle is 90 degrees. This is X and this is Y. It's basically to calculate this length. It's just to try to explain it. You don't have to understand it. Just you don't need to learn it properly. You have just to understand it properly. Just slightly what I'm saying here. You got X and Y in any angle that we've got. Basically 90 degrees in here. To calculate this length in here, it's gonna be this side square plus this side square, all square roots. This is our X, this is our Y. X square plus Y square, all square roots is gonna be the length of this side. We put this sign in here just to make it always positive, because the modulus of -3 is 3. The modulus of minus any negative number is a positive number. This is the length. This is what we represent, how we represent the length. But these two sticks basically to keep it simple. This is the modulus. Now for the argument. Argument is this. If argument, how to represent it? We said argue ARG of Z1 or Z2 or any complex number we want to use. Argue, what is it? Is equals in here tangent of minus here power -1 y divided by x with positive number. It has to be +2 here. What that means, and this is our basically angle here in our example, because we said Z1 is gonna be gamma 1. Here basically what I'm doing here, we've got this angle in here. I need to calculate this angle. This is argument of this complex number. Again, here's our complex number, just to answer what I'm saying here. This is real, and here we've got imaginary numbers represent the reals, and this here represent the imaginary numbers. Here we've got basically 1 2 3 4 1 2 3 4, say -1 -2 -3 -4 is same in here, and then I want to represent my this z1, which is this complex number, 3 plus 1 times I. Here we've got 3 for imaginary number, let's say 3 for real number, sorry, 1 2 3, and then 1 for imaginary number is going to be here. This is our z1. We've got, this is here, there we go, just to keep it simple. It's as simple as this. You don't have to complicate it at all. What we're trying to do here, we said if you want, this is the modulus, this is the length of this distance in there from 0 to z1. The length of it, it has to be positive for represented with this sign in here. It's gonna be x squared plus y squared, all square roots of it. We're gonna find the length of z1. Now we try to find this side in here, this one in here, which is, we call it gamma. You can, again, you can call it alpha, beta, gamma, any symbol you want to call it. It's totally up to you. For me personally, I choose this symbol just to distinguish the names, and then I won't get confused. I can't say x because I've got another x in there. I can't say y because I got y. Anyway, this is the argument, this is the modulus, and this is the argument. We said we represent it by ARG. Okay, now argument of z1. I have to say z1 because I have to say argument of what, which complex number, which is z1. Then I have to calculate gamma 1. Here to calculate this gamma 1, here we've got tangent of gamma equal y divided by x. This is the tangent, but I need gamma, then gamma equals the tangent power minus 1 of y, this side in here, y divided by x. Has to be, it's going to be positive number here, and then we're going to find my number. Now this argument, which is gamma here, is going to be gamma here, it's going to be basically between minus p and then p. P here is 3 plus 3 1 14, and then here minus, and then here 3 14 plus, sorry, 3 14 plus. This is in numbers, but in angles is gonna be here gamma. This one's gonna be 100. Basically here we've got 180 degrees, and then here 100 minus 180 degrees. But when you do the numbers, you're gonna put minus 314 and plus 314. Why we gonna use this to calculate this gamma here? We have to go against the clock. Basically here, if we got clock, is going to be 1 2 3 4 5 6 7 8 till 12. But if we want to calculate, it's going to be from x and we go up, not this way, not this way. We're going to go basically the opposite. Sorry, my bad. Yeah, basically here in a clock, basically we're going to go 1 2 3 4 this way in here, but we are not going this way. To calculate this gamma, it has to be the opposite way, which is this side in here. Yeah, then in this side, if you got your, basically if you got your gamma this side in here, basically if your real number is positive, you got it this side, you write it as it is. You have to focus on this, just and said with me, this is the most important part in all this sign of complex numbers. If you got your gamma this side in here, basically your real number is positive. If your real number is positive, what that means, your gamma, this angle in here, forgot about gamma, the angle gonna be here. If the angle gonna be here, basically when you found your results, you write it as it is. Gamma equal results you found here. If your real number is negative, guess what? Real number negative, then it's gonna be your, let's say here we said 3, let's say it's minus 3, minus 1, minus 2, minus 3. Then my real number gonna be here. So this gamma from here is going to be this side in here, then it's going to be here. Let's say gamma 2 or any other name as we said. So to calculate this gamma, basically the direction is going to be this way in here. So it's going to be this side in here. But I need that, we said it has to go from x, from here. It has to go from here. Definitely need to go from here and up. It has to start from here. But our gamma, this side in here, when the real number is negative, it doesn't start from here. It starts from here. It goes from here till here. Look. Here till here. Which is wrong. Then what I have to do, I have to find this number first. And then what we're gonna do, I'm gonna take all this angle here and take off this side. And then we're gonna have this left. I hope you understand this. This is because this is the trickiest part. Again, what I'm gonna do, if real number is negative, yeah, then our gamma gonna be this side. My angle gonna be this side, which is gonna start from here till here. But for me to calculate my angle for my complex number, which is my argument, if I found that, what I have to do, I have to start from here and go all the way up and then calculate my gamma basically here, here, there, whatever, which side, 1, 2, 3, or 4, whatever I found the end. But in technically what I found my angle here. So instead of finding this, which is I can't write it, it's helpful, but I can't write it in my response. I have to write this angle from here till here. What I'm gonna do, I'm gonna take all this angle in here. What is this? This is 180 degrees, isn't it? Which is P. Minus what? Minus this little, my angle, which is this little gamma, which is minus gamma, and this is my result. P minus gamma, and this is my result. This is what we said, P, it has to be between minus P and then P. Remember, if a real number is negative, basically your gamma gonna be here. So you have to take it, you can't just write gamma. Once you found that, you still got another step, which is P minus gamma, and then you're gonna find your argument, you're gonna find your angle that you need, and this is the argument from here till here, arguments of your complex number. If you found that your basically your angle here, it's basically have to say what you have to say here, because we found that this side in here, if basically here real number is negative and then the imaginary number is negative 2, basically this is your z here. So what you have to do then, this is your argument, this is basically your let's say gamma 3, this is your angle, but the angle we said you have to start from here and go all the way. What I have to do, I have to add this to all of this on the top, which is, this is P and this is gamma, which is gonna be P plus gamma. This is if you got in here real number negative and imaginary number negative. Now the last one, if you got a real number positive and imaginary number negative, here basically here, as simple as this, what you have to do, this is basically, this is your here, this is your what we call it, this is your gamma 4. To calculate this gamma, what you have to say it's just minus. You calculate it, you're gonna find it positive, and then what you have to say just minus. Once you find that minus, why you're gonna find it positive? Because we said y, this symbol is always has to keep it positive. Y divided by x, you're gonna find it positive, and then you said is the symmetry of it, which is minus, which is gonna be negative. What I'm gonna do, I'm gonna just clear my board and recap this side, the last bit in here, recap it basically just to understand what I'm talking about, to make it easy for you, because it's simple, it's not complicated. For today we're gonna just do theory, and then in the next video we're gonna do some practical exercise to understand it, because it's easy, simple, and you don't have to panic or to make it complicated. Okay, what I'm doing here, so I just need to clear my table, and then cool. Okay, there we go. What I can do here, all right, again, I'm gonna write just x-axis and then y-axis. We said this is imaginary number and this is real number. Okay, then we've got in here, let's say 1 2 3 1 2 3 1 2 3 1 2 3. We've got in here, let's say this is z1 and this is in here z2 and this in here z2, and we've got in here z3, and then in here we've got z4. Cool. Okay, then what we're gonna do in here, we're gonna just try now to see all different cases we were talking about. First, for Z1, we're gonna call the gamma 1 in here, and then in here what we found gamma 2 here for this, and then in here we found gamma 3 for the third complex number, and then in here this is Z4, we found here gamma 4. But remember, just to keep it simple, I kept the same real number here. They've got the same imaginary number, and then here we got the same real. Here we got same real number, same imaginary number, same imaginary number. To keep it simple, here for gamma 1, this is the argument. A simple argument ARG. We said for Z1 equal gamma 1 as simple as this, and gamma 1 equal tangent or TNA power minus 1 of y divided by x modulus, which has to be positive. And then from here, because we said if you want to calculate gamma 1 or any the angle of the complex number, have to go against the clock, whilst basically just this way here instead of going that way here. Okay, then because here we have to start from here. Remember, you have to start, this is the starting point here. Definitely have to start from here. You don't have another starting point. You to calculate, so you have to start from here. We start from here, we go up, done, boom. This is gamma 1. And then we have to calculate this. But to calculate it, we found our angle, but the angle is starting from here till here, just here. But we need to start from here, not from here. Then what we have to do, our argument is going to be, we found our angle, the argument is going to be all this angle here, which is 180. Argument of Z2, which is going to be 180, all this angle in here, minus this one in here, which is gamma 2. And then we're going to find our argument for Z2, which is all this, because you have to start from here until it goes up, around, or up till Z2, and then we're gonna find our argument. Now, to find our argument for Z3, argument for the third complex number, have to start from here, as I said, and we need to go all the way until we reach Z3. But we found our angle, but our angle starts from here in other direction from here till here, which is not ideal for us. What we have to do, have to basically see what trick we can do it, just slightly until we get it into Z3. Basically what I have to do in here, we have to say it's P 180 degrees plus this little bit, which is Q3 gamma 3, sorry, this argument of Z3. And now what we have to go for is argument of Z4. Argument of Z4 basically is this one, which is start from here and finish it here. Basically, but we don't need it to go from here to up here. We need it to opposite, to start from here, as we said, from here, and to go down here. To start from here and to go down here is the same as this, but in different direction. Basically, if this is going up, this one gonna go down. And we knew this angle in here, this gamma in here is gonna be positive. Then what we have to do, I have just to say it's minus gamma 4. It's basically what we found in here. That's gamma 4. We found that with the radius, obviously basically all our angles has to be with the radius, but we're gonna find it in your calculator. But just put it scientific, and then it's gonna be that simple. Just calculate it straight away. You don't have to use your brain at all, which is thanks to the technology. What we're gonna go in here from, basically we found that let's say 1.3 is gonna be here minus 1.3, because it has to be the other way around, basically, because we said it goes in here, we found it, but basically we have to start from here and go all the way, and or from here it goes down here. That's it. And then we're gonna find that you're gonna go minus Z minus gamma 4. This is all we need to know for your complex numbers so far, in terms of how to put your complex number in geogram. All we're gonna do now, basically from this video in here, what you have to do, you have to make some applications, because you more exercise you do, the better it gets. In the next video, what we're gonna do, I'm gonna go through some basically applications to make it easy, because it's easy and simple. This is just the theory. It looks slightly bit complicated. I try to simplify it, but it still looks slightly bit complicated. But in the next video with the numbers, is going to be that easy, that simple. Is going to be just piece of cake, and game is just to play around with numbers and see what direction you are in, what size you are in, and use your calculator. As simple as this. If you need any question, drop me a text. I'm more than happy to help, and I'll see you in the next video for more practical